Hey, welcome back to the Betamax Rebel Outpost channel. This is Will. Well, I hope everybody's having a great 50th anniversary celebration still. I got a new one here for you on my SL-6200, the first Sony Betamax VCR from 1975. And I've been doing a ton of work on this thing. It seemed to do okay at first, but then the more I kept testing it and picking and prodding at it, I lost color on one of my only old Beta 1 recorded tapes that's recorded in color. It was playing color at first and then it flickered out, and I kept having to clean the heads, and the picture output just kept getting worse and worse the more I tested it. So I'll show you what I mean by that. So here's the problem. Here's the RF output from the head amplifier going into the input of the IC1, which is a CX134A. And as you can see, the B channel is very strong, but the A channel is lacking in amplitude. I can't get it much higher than that, even when I try to balance it with the dump controls. And it's very possible that these tuning capacitors here, these variable capacitors, could be worn out. There's a little tool I made here to adjust this variable capacitor. Now if I twist this pot, I can change the amplitude slightly of the A head right here. When I adjust the B channel, which is right here, then B channel rises and reduces as expected with the tuning of that variable capacitor. I have a feeling what I have here is I have a worn out video head disc and perhaps a damaged A head, because no matter how I try and tune it in, as you can see, the A RF output is kind of soft. Like it's not nice and sharp like the B channel is. It seems kind of blurred out. And here's the output right now. As you can see, it's still pretty noisy. I'm going to go ahead and play this test tape, this alignment tape that I forgot I even had. Definitely got to be a video head problem. This is the clearest that I've been able to get out of this machine so far, and it's stuck in the monochrome mode. So I'm going to have to change out that head and get into that drum somehow. So we'll just get this guide out of the way first. Set that aside for now. Okay, let's give this a shot. Okay, there's one. Yeah, this one's a lot easier to get at. Okay. Okay, and there's the upper drum of the SL-6200. RS1. Here's a closer look, and it makes me wonder if this is a replacement head, because we do have marks here scribed into the drum. I think I want to check to see if maybe they didn't zero the head out with the micrometer. That's pretty good. Okay, first time opening up RSV5 A6762024B. I have a couple of these, but I've never needed to use one. I just want to take a look and see exactly what I'm dealing with here. This is the head for the SL-8200 and the SL-8600, and I don't know what the differences are between an 8200 head and a 6200, 7200 head, but let's see, there it is. It's got two PG magnets. So these appear very similar indeed. The 6200 also has two PG magnets, just like this RS5. Okay, another thing that I want to try is to test those video heads on my video head checker. Okay. Well, I know it's not a 7. Battery is good. Calibration is good. Oh wow. And that's the so this could be the problem. Okay, we've got a good battery. I'm going to calibrate that. Battery, cal. There, and measure. It's below calibration. This is a shitty connector here. Calibrate, measure. Oh, it's going fucking crazy. Calibrate. Oh, okay. Make sure these aren't shorting out. Calibrating, and it always goes lower than the cal setting. Yeah, I've seen that with really bad heads before. Yeah, it's below. Oh well, so this head is dead. So it's in the red zone. Let's see what happens with the B head. There we go. Okay, calibrate and measure. Cal. Yeah, it goes below. So it's a little bit better than A head. As you see, it's not quite at the red yet, where the A head was right at the red. That could be the reason why I still get picture, because of the B head still has a RF output, but the A head is way down here. Alright, I'm going to go ahead and take the video head disc out. What have I got to lose, right? I've got to see how this one compares to the RVS5 video head for the SL-8200, 8600 series. And if they're physically the same, I'm going to go ahead and try and see if I can make it fit in. Hopefully it's a direct fit. If it's a direct fit, I might be in luck. Okay, that wasn't too painful. Oh shit. What was that dropped? Okay, and there it is. There's the head disc for SL-6200. I think. I mean, I believe this is a replacement disc. The upper drum had been removed in the past for some reason, and it could have been very well to replace this disc. While I'm in here, I may as well clean up areas of the drum, the inner drum, that otherwise are impossible to get to. It's also good to check for any burrs with a fingernail, because there's been other people in here, and who knows what they've been doing. So many times I've checked drums and found the edges are all burred up because somebody was fiddling around with a screwdriver or something. Like I feel one right here. There shouldn't be any burr right there. Right there. I'm going to see if I can rough that up a little bit. That should be fine. I don't want to go too crazy. Just want to rough it up just a little bit. I don't believe I have anyway, an upper drum for this generation of Betamax. So I'm just going to have to make do with what I have with the original drum. May as well clean it all up too while I'm here. Okay, and we'll give it a quick resurface. Again with my worn down sandpaper on a rubber brick method. On a flat rubber brick. Get it nice and wet. I just use Windex because it's got some viscous to it. So anyway, that looks like an improvement. Okay, so I'm going to try installing this RSV5. Trouble is with some of these, the older ones, I know it's sometimes important to adjust the dihedral angle on one of the heads. I think it's A head. Okay, it's on the lower disc, and because you see how it can move back and forth like this, that's why we need to use the micrometer to dial this into perfect center 0. Otherwise there's going to be so much mismatch, and there's going to be imbalances in the drum rotation, and it's going to lead to all sorts of problems if that disc is not perfectly center. And here's what a new measurement should look like. Just cal that up and measure. And that's what a new head usually looks like. I usually see it between a 7 and a 5. Here's my first try at it. You can see I'm way off. There's kind of a high spot right there. It frees up, and it's a high spot, frees up, another high spot. So it's just that one high spot, which is what I expected to happen. So now I have to loosen the screws and kind of bump it over a little bit. I think I may have found center. What I like about this head design is I don't have to worry about the drum crushing the heads when I go to install the upper drum. It just rests on it like so. as I put in each little torque screw. Okay. Okay, my little torque wrench. About there's good. At last, some good news. So, the SL-8200, 8600 head disc fits the drum. And I thought it didn't at first. I just didn't have the Torx screws in tight enough. It's a very tight specification. If they're not in tight enough, and if these washers aren't pressed down 100%, and I used this bar of aluminum to press down as I was tightening the Torx bits. If it's not pressed down, you're going to get scraping noises happening with the disc, the rotating disc, and the stationary upper drum's inner surface. But I've got it, and no scraping noises. The new drum fits, so I'm excited. This might actually work. There it is. Brand new inner head disc and resurfaced upper and lower drum. Let's see how it does. Look how responsive that is. Better than I expected. Looks like the color's trying to come through. Really looks like it wants to come in. There it is. Not bad. Now I just have to readjust the servo, it looks like. There's some sort of a timing error occurring. So that proves that the SL-8200 and the SL-8600 video head disc will work in an SL-6200 and an SL-7200 most likely. Wow, it's back. Wow, this tape plays a lot better. Let's see how the RF output looks. Yeah. Okay, there we go. Very interesting indeed. Okay, I loosened up the CTL. Tighten down these screws. So that's looking really good. And the thing too about working on this machine, I find, the more I work on it, the more I love this machine. It's a lot of fun learning about this machine. I mean, it's just so simplistic, right down to the RF playback amplifier and the dropout compensator, the CX134. You have a rotary transformer, 1-to-1 transformer, so they're both equal. And that goes to the transformer T2, and that would be right here, T2. Okay, so there's some amplification going on at this point on. Basically, you have a 1-to-4. So it's 4 times the input at this stage, and you can optimize that with the variable capacitor and variable resistor before it becomes the output here at the FETs. And so this is the A channel input, and the B channel is the exact same thing, so there's no need to repeat all of this. It just, they come through here, the cascode amplifier. It's supplied by, the whole thing is supplied by this 6-volt rail that's derived from the 12 volts. It goes to this equalizer section. So head A pops out here at pin 20, and now you can flatten the response of the A channel output, and same with the B channel. You can flatten that response, and then you can use the center VR6 potentiometer to balance out the channels so that they're both the same. And so then they meet over here at this internal switch, A channel, B channel switch, and that's all getting switched from the RF switch pulse. That's being produced by the PG coils connected to the CX138. Once it leaves the amplifier stage after the switching process is going on by way of the RF switch pulse at pin 18, goes to this amplifier points right here. It goes to these two amplifiers and arrive at pin 16 and 17 into this resistive mixer circuit. The first tap right here at our 28 and 29 enters into pin 14, and that's for your black and white mode. And that's controlled by pin 12 right here, the color killer signal that's received by the CX137. We can talk about that later. And then the second tap goes through is the same RF information, but now that's going through a high-pass filter. So that's what you would want for your color mode, because you don't need color components coming in through the YFM stage when you've got the color components off the third tap going over to the YC board. This is your chroma output. So now we're going through a limiter preamp, and then it goes over to the main limiter, which keeps the level at about 25 dB according to this book. And then it's over here available at this pin at the dropout compensator switch. This is the dropout compensation stage. It also, the same signal also goes over here to this DOC limiter, detection stage. Sensitivity is set up here by C36 and R40. And then that detection stage is connected to a Schmitt trigger. At the detection of a dropout, the dropout limiter and the detection form a pulse. And the detector will detect this pulse and tell the Schmitt trigger to close the switch, and the Schmitt trigger will toggle this dropout compensator switch every time that a dropout is detected, and that will cause this hysteresis here with Q5 to turn on and off, shorting itself out, shorting out R43 by the sensitivity setting right here at BR8. And that allows the RF available that was one horizontal line ago to be available here at pin 6, so that it becomes the RF output again through the Q6 emitter follower transistor, and then over to the YC board for demod. So I'm going to adjust the dropout compensator by adjusting the sensitivity potentiometer VR8. And right now it's about a quart away from its original setting. So if I was to turn it to the left, you can see the dropouts becoming a lot more intense. If I turn it to the right, they seem to disappear more till the picture is pretty clean. Okay, yeah, you see the sharp blacks? Now I turn it back, and they're not as bad. And now it's turning kind of sharp white. So I think right about there is probably perfect. That's about as good as it's going to get. And lastly, to conclude this video, I just want to test out record. So right now the unit is in record mode using a nicer condition Sony ESX L750. See how it did. And so yeah, there's still some picture wobblies going on. That could have to do with how I installed the drum. But this also could be due to the fact that the machine still has the original belts. And the only belt that I had to replace to get this machine operating was the threading belt. The capstan drive belt, the drum drive belt, they're all original belts. So they probably could use replacing. They're 50 years old. But for 50 years old, this machine is doing great with the new head installed. More has to be done, but this is a really good forward advancement in getting this machine back up to par. It's a piece of 1975 brought back to life. The first BETAMAX VCR. SL-6200. Well, that's going to do it for this one. Thanks again for watching. I'll be back with more BETAMAX repair videos in the near future. And I think I'll end this one with a special clip as tribute to what my BETAMAX machines were used for back in the day. So enjoy, and I'll see you next time.